Okay, we are on section 3.3, day 1. Now you guys won't talk today because your voice might show up on here, right?
Of course.
Say hi to Sydney.
I've had to watch these before. The voice never shows up, so they're always kind of clueless.
The voice does too show up, if you choose it to show up. All right, so on 3.2 we were concerned about whether the two events were independent or dependent. Because when we found that second probability, we might have to change the sample space. Today, we're going to be concerned about whether the two events are mutually exclusive. So mutually exclusive events cannot happen at the same time. Oh yeah, it didn't even come close. Exclusive events cannot happen at the same time. So they have no overlap in their sample spaces. So let's take a look so you know what I'm talking about. So the question is, are the two events mutually exclusive? Event 1 is going to be looking to see if we roll an even number on a die. Event 2 is going to see if we roll a number greater than 4. Would those two events be mutually exclusive? What's your guess? Why are you saying no, Dean?
Because an even number. 4 is, because 6 is an even number.
Right. Because what are we looking to happen here? If I'm looking to roll an even number, what's considered a success here? What numbers are even? 2, 4, 6. Now I'm looking to roll a number greater than 4. What numbers are greater than 4 on the die?
5, 6.
5 and 6. Is there any overlap here? Yep. So these are not mutually exclusive because they share an outcome. Okay, event 1, same idea, is to roll a prime number on the die. Event 2 is to roll a number greater than 3. Would those two events be considered mutually exclusive?
What prime numbers are not?
Okay, what are the prime numbers again?
1, 2, 3, 5.
Is 1 prime?
Yes.
No.
Not?
1 is not prime because the definition of prime says that the number has to have two different factors, two distinct factors. And 1 only has one factor, because it's 1 times 1, that's only one factor. So 2 is the smallest prime number. Then, the next one, 3 is prime because it's only 1 times 3. 5, on a die we stop. 6 isn't prime, 4 isn't prime. What are the numbers greater than 3? 4, 5, and 6. So are we mutually exclusive? No. They share the 5.
Are they not going to be mutually exclusive most of the time?
No. I mean, they will be sometimes. So we better do one that is. Roll a number less than 2. Roll an even number. Mutually exclusive or not?
Mutually exclusive.
Just saying yes to that. What are the numbers less than 2 on the die? Just the 1. Even? 2, 4, 6. So these are mutually exclusive. Okay. The reason we have to talk about that is when we get to the probabilities that have ors in them. Okay. Remind me to do this every day while she's gone,
All
in
right.
case I forget.
We'll try.
Okay. So it's not my fault that if we forget, it's their fault now. Okay.
Dean takes full responsibility.
Placing
Yes.
the blame somewhere else.
All right, so,
Sydney, we're sorry.
oh, that's not an example, sorry. It's a definition.
And
So if you're looking at the probability of one thing happening or another thing happening, there's a little formula. Or tells you to add the probabilities together. If A and B are mutually exclusive, that's as simple as it gets. If they're not mutually exclusive, the formula changes. You're still going to add the probability of A happening plus the probability of B happening. But if you have double counted an outcome because they share something, you've double counted it, so you have to subtract off the overlap. I call it the overlap. The book calls it A and B. I just like it overlap. It'll make more sense when we do it. Okay. So now let's do some probabilities with some OR connectors and see how these two formulas work. Okay. What's the probability that you roll a number greater than 3, or you roll an odd? So, I see the word or. Or means add the two probabilities together, but then you have to subtract any overlap. That's the one thing you've got to remember. So, what's the probability that I roll a number greater than 3? So how many numbers on the die are greater than 3? 4, 5, 6.
1 and 2.
So it's 3 out of 6, 1/2. Plus, what's the probability that I roll an odd? 3 out of 6 also. But which ones are the odds? 1, 3, 5. Did we double count anything? Because according to this, what should be the probability? What's 3, 6 plus 3, 6? 100% chance. Well, we did double count something. What did we double count? The 5. There was one outcome that got double counted, so we subtract 1/6, the overlap. So what's the real probability of me rolling a number greater than 3 or an odd? 5/6. So all you have to remember on the ORs is to subtract any possible overlap. Okay, now we're going to pick a card from a deck of cards. What's the probability that you pick a face card or a heart? So what are those face cards again?
Jack,
Jack, King, and Queen of what?
Hearts, diamonds, spades, clubs.
So you got all 4 suits. So how many cards are there here?
12.
12 of them. Because there's 3 hearts, 3 spades, 3 diamonds, 3 clubs, a total of 12. So what's the probability of drawing a face card? 12 out of 52. Your sample space is 52 cards on a deck of cards. Or means to add. Now what's the probability that I draw a heart? 13 out of 52. Was there any overlap? Did I double count any cards? 3 of them. So I got to remember to subtract off those 3 cards that got counted here and they got counted here. I can only count them once, not twice. So you can see you don't want to reduce your fractions until you're all done. So we've got 25 minus 3 is 22 out of 52. 11 out of 26. Book will probably give a decimal there. Let's see. B or AB. Okay, this must need the table in the... Okay, number 4, we have to have the information from the book. We're going to be looking at blood types. We're going to be randomly picking a person and asking for the probability that your person has type B blood or type AB blood. There you go. And according to their table, let's see, I'll show you the information. This is 3233. 33. Number 4. Okay, here's their table of information. So we were looking at picking a person with type B blood or AB blood. So what's the probability of picking a person with type B blood? Can you read this table? Is there only 37 people with type B blood?
No.
O plus 8, 45. So the 45 out of 409. And then AB blood? 16 out of 409. Is there any overlap between people that have 2 blood types at the same time? These are mutually exclusive. You can't have one person with 2 different blood types. So there's nothing to subtract. So it's just going to be add the B probability, add to the AB probability, and that'll be it. So it'll be 45 out of 409 plus the 16 out of 409. But just to keep in the habit, when you add, think, do I need to subtract anything? Just put a 0 there so it trains your brain to always ask, do I need to subtract anything? 127. So we get a final probability of 61 over 409.
So whenever it's or, you're going to add and it's multiply?
Correct. Train your brain on that too.
Wait, on what?
And is multiply, or is add. Same table. What's the probability that you pick someone with type O blood, or you pick someone that is Rh positive?
What?
RH.
Rh is the Rh factor. You either have a positive Rh factor or negative. Everybody's got one or the other.
Oh.
It's your Rh factor.
Okay.
Most people have a positive Rh factor. So, or tells me to add. So, according to the table, what's the probability of picking someone with type O blood? 184 out of 409. Everybody see it? 184 out of 409. What's the probability of picking someone with Rh positive?
The positive in general or just for all?
Just positive.
344.
Yes, because there's this, all of these people, 344 of them are Rh positive. So that's 344 out of 409. What am I looking to subtract?
The number of positive O blood.
Which one's got double counted? The 156, because we took these two here and added them. Then we took these 4 here. This 156 got added into both sets, and they only exist once. So we got to subtract off 156 out of 409. And then whatever that is. Anybody get that? 372. What's the probability that the person you pick is Rh positive, given that they have type A blood? Am I multiplying or adding?
Not
Neither. Neither, neither, whichever one you want to say. This is just a conditional probability.
Is there?
This is a trick question. So we're looking for the probability that they're Rh positive, given that they have type A blood.
139.
Rh positive, given that they're type A blood.
139 or 1.
Yes, given that means I'm only looking at this column, I'm covering up the rest of it. And it was positive, so 139 out of 164. So conditionals just are reducing your sample space. That was just thrown in there just to see if you remember. Let's see, I think we're getting close here. What's under here? Due number 13 and 17 on Friday. Oh, okay, that's nice.
So that's it?
No,
Dang.
So we're only doing number 13?
no, we're gonna do a little, oh, this is 17, yep, we're gonna do that. Oh yeah, we got time. Plenty of time. We're way ahead of the game from yesterday.
Good.
Okay, 17, we'll start it. Okay. Oh, what could I call it? Oh, that's all right.
Example
So,
5.
yep, example 5. Or 7 we're on? Okay, 17. All right. In a sample of 1,000 people, 120 are left-handed. If 2 unrelated people are selected at random from the sample, find the following probabilities. Both people are left-handed. At least one of the 2 people is left-handed. Neither person is left-handed. Okay, blah, 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 blah. So when we pick our person, what are we concerned about?
Right or left hand?
Right or left-handed? And we're picking 2 people. I'm assuming without replacement, even though it doesn't say it, we're going to keep the person out.
I've got a question.
Yeah.
Dominant hand a genetic trait?
I think so.
Or is that just something that's developed?
Yeah. So let's take the 95 seconds to make, or the 59 seconds to make the tree diagram. Pick your first person. What are you going to look at?
Right or left?
Right-handed or left-handed? Let's see what those probabilities were.
120 or 1,000?
120 out of 1,000 are left-handed.
Congratulations.
So how does that help you get the right-handed people?
Subtract that.
Subtract from 1,000, that leaves us with 880 out of 1,000. Now you go in and you pick out a second person. Decide if they are right-handed or left-handed. So what's my sample space on all 4 of these probabilities?
999.
999. Got it? I can put those down, all 4 of them down right now. They're all out of 999. Okay, so I started with 880 right-handed people. I picked one out. So what's the probability of the second person being right-handed?
879.
879. What about left-handed? 120. All of them are still in there because this is the branch where I picked a right-handed person first. Now we come down to the branch where I did pick out a left-handed person first. So how many right-handed are there? 880. And then how many left? 119. Okay, the first probability question was find the probability that both are lefties. How do you rewrite that probability? Is this a and or an or? And. So probability that you get a left and a left. So what are you supposed to do with the probabilities? Multiply. And now you've done all the thinking, you just got to multiply the two together. So it's 120 out of 1,000 times 119 out of 990. You don't have to do it. We'll just, this is fine. You'll know where, this is more important because you know where the numbers came from. The final answers you guys can save for the quiz.
It would be a big number.
Yeah. At least one is a left-handed person. There are a couple ways to do this one. Because this tree is so small, I'm going to show you two ways to do it. There's the formula way like we did yesterday, the 1 minus, or you can think about, well, what situations satisfy this?
Didn't we do this yesterday? You just subtract the...
That's the one way, it's the formula. I want to do it not that way. I want to do it way, Macy kind of struggled with that, I think, with the 1 minus business. Think about what outcomes am I looking for if at least one person is left-handed. Give me a situation. A right-handed person and a left-handed person. Is that the only situation?
No.
What else?
Right.
Or what else satisfies that situation?
LR.
Left and right. Is that the only two situations?
No.
Or L and L. Are those the only three situations where at least one of them is left-handed? So, I've got a right and a left. How do I get that probability? Right and a left. So I could multiply 880 over 1,000 times 120 out of 999. What does OR tell me to do? Add. Now this next probability follows the left person first and then the right one second. So it's 120 or then I do the two lefts. Okay, that's the long way to do it, just to add all of the different situations together. Okay, the short way was to do the 1 minus. What's the one branch that we did not figure out here? Right. So the second way to do it would be 1 minus the probability of getting neither one left-handed or right and right. See how that works? So it's 1 minus the 880 out of 1,000 times the 879 out of 999. Both of these will give you the same answer. So you can add up all of the situations that work for you, or do 1 minus the one situation that doesn't work. All right, and then the last one is a story problem one, 13. This is it. Because the story problem ones seem to be the toughest ones. So it says a company that makes cartons finds that the probability of producing a carton with a puncture in it is 0.05. The probability that a carton has a smashed corner is 0.08. And then the probability that a carton has both things wrong with it is 0.004. All right? So are the events selecting a carton with a puncture and selecting a carton with a smashed corner mutually exclusive? So you got to ask yourself, can they happen at the same time? Yes. So they're not mutually exclusive, so they have overlap. So if the quality inspector randomly selects a carton, find the probability that the carton has a puncture or a smashed corner. So it's the probability of having a puncture or smashed corner. Or tells me to add, but then I got to remember to subtract any possible overlap. So what was the probability of the puncture? 0.05. Smashed corner? 0.08. Anytime I add, I want to subtract any overlap, and the overlap was 0.004. They gave you all the values, you just had to know what to do with them. And then whatever that comes out. .126. All right. Your assignment today, page 129. Okay, I'm thinking that's good. 12. 14, 16, we did 17. I'm throwing 18 in there also. 18 also, then we're done. Okay, we'll look at a review tomorrow for a smaller quiz. And there's only one section left in this chapter.
So quiz on Thursday?
So yes. Oh, let me put that back real quick. Oh, it blurred out. Oh shoot, I gotta sit back. Okay, good. Let's see.